So we took a look at the law of sines, and now we're ready for the law of cosines. So what we needed for the law of sines is the complete ratio. We needed a side and the angle across from it in order to be able to set that up. Well, the law of cosines is going to apply when we don't have that complete ratio, essentially. There's two possibilities. Maybe we have all three sides, but none of the angles. Law of cosines can help us there. Or we have a combination of sides, and so we have two sides and a single angle. Law of cosines can help us there, but in such a case where we didn't have the complete ratio. Now, I'll talk you through more as we move forward here, but the law of cosines is derived by putting an obtuse triangle right on the x-axis. And there's definitely some trickery here of just defining the sides in terms of cosine and sine. So we've just defined all of the sides of the triangle based on some trig identities and some extensions. Now, I didn't work all the way through this, and I'm not going to take you all the way through it, but it just basically comes after you have defined the sides in that fashion, then you just do the Pythagorean theorem, and you create the law of cosines. So again, I'm not going to take you through the proof of that. I didn't spend much time looking at it, but that's the idea. But here's the punchline. The punchline is we create this set of equations. Now down here we have an alternative version where we're just solving for the angle. But so here's what we've got. We can find a missing side if we have the two other sides and the corresponding angle. So what, or I guess the alternative side. So I'm not saying this very well. If I am looking for this side, if I have the other two sides and the angle across from it, then I can use the law of cosines. Now, look what I have here. I do not have the complete ratio. I'm looking for that. So I have two of the sides and either this angle here to look for that, or I could have all three sides and be looking for the angle, which would allow me to use the alternative versions. I don't even think memorizing these or having these on the formula sheet is all that useful. Just use this one set of equations. If you want to find the angle, then just do some basic algebra to solve for it. That's where these come from. Let's take a look here. So here's what we have. I have two sides and the angle in between. Now the problem here is I don't have a complete ratio, so I cannot use the law of sines. Now the law of cosines says if I have the other two sides and the angle opposite him, then I have everything I need. So it really just becomes plug and chug. So I'm looking for b squared. I've put in the other two sides, and then I'm using the cosine of the angle across from the side I'm looking for. Just plug and chug. We crunch all that down. We take the square root. We get b is approximately 6.013. So nice and straightforward. Okay. Now, we now have all three sides. So we have a choice. So this turns out to be 6.013. Now, if they wanted the whole triangle, we have two angles that we're going to need to find. Now, we now have a complete ratio. So if you wanted, you could use the law of sines, but there's actually a disadvantage here. If we use the law of sines, we get alpha is 56.3. Now, here's the problem. We'd have to check to see. So inverse sine is giving us only quadrant 1. What about quadrant 2, that whole mess we saw in the last video? Well, here's the beauty of the law of cosines is actually going to avoid that problem. So they reason through based on the diagram here that we didn't that the angle that we wanted is 56.3, and they didn't do the bizarro triangle, but it appears as if one would exist, but they ignored it. But so here's the advantage of the law of cosines. The law of cosines is, remember how it went from 0 to pi? Inverse cosine goes from 0 to pi. So if you use the law of cosines to find the other angles, you don't have to worry about any bizarro triangles or any weird things, because inverse cosine will give you the unique answer. So that's the advantage of the law of cosines here to find the other two remaining sides. Okay, so let's try this. So we've got, I've got the two sides, and I have the angle in between them. So this is everything I need. for the law of cosines. So it's going to be b squared plus c squared. Hold on, do I have this down? Okay, those are the pieces we need, so let's just plug and chug. A squared is going to be 12 squared plus 24 squared minus 2 times 12. Okay, now there's a lot of crunching to do here, so give me just a second. So we're going to do cosine of 30 times 24 times 12. So this all turns out to be negative 498.83. This is 144. Okay, so a squared equals all of this. So let me find this final number plus 1. Okay, so I get a squared is 221.17. So I'm going to square root that. And so a is going to be 14.87. Now we're talking about the sides of a triangle, so negative isn't going to make any sense. All right, now what we have is the three sides and an angle. So we could do the law of sines here because we now have the side and his corresponding angle. And although the math is easier, I'm going to go ahead and do the law of cosines because it's not going to create any alternative. Triangles. So let's look for. Yeah, so let's go ahead and look for angle beta next. So that's going to be b squared equals a squared. Okay, so this is going to require some more rearranging, but it's not going to be hard. So we're going to do 12 squared equals 14.87 squared plus 24 squared. Okay, so the law of sines is mathematically much simpler, but let's go ahead and crunch this to see that it would. Now I'm doing this all in one shot here. So, okay, so far I've got So I could have just looked up the alternative version of this here, but I'm going to divide now all of this to get cosine of b alone. So I'm dividing by negative 2, dividing by 14.87. So here's what I've got. I've got cosine of beta equals 0.915. Now the reason I did this is that this is going to give me a unique answer because of the inverse cosine is what I need now, and that does both the first and second quadrants, which is everything I would need for a triangle between 0 and 180. So this is going to get me a unique answer. Okay, so I get beta. If I inverse cosine this, beta is going to be 23.78. Okay, so I now have 2 of the angles, 3 of the sides. To find that remaining angle, I would just do 30 plus 23.78. So this gets me 53.78. Take that away from 180, and I get 126.22 is, well, this book calls it gamma. Okay, so I have my 3 sides, I've got my 3 angles, and I've got everything I need. Okay, now we're going to have the alternate version here, which is really what we already just did here. Suppose we have 3 sides, but we don't have any of the angles. Well, you could use the alternate version of the formula that solves for the cosine of the angle, but they've just done it like I just did. So first we're finding alpha. So we just said this is the version of the formula we need. 20 squared plus b squared plus c squared. Just plug in and chug in. Solve all this down. We're going to get to cosine of alpha is approximately 0.61. This is going to get us a unique angle because it's inverse cosine, so we get 52.4. So now I have three sides and one of the angles. We could just do it again. Again, law of sines is much easier mathematically, but you have to think through the logic of the ambiguous cases that they call it. So what we could say, oh, did they even do it? Oh, they only wanted the one angle. Okay, so they just wanted alpha. So, but we could have done the law of cosines again to solve beta. And once we know beta, if you know two of the angles in a triangle, you know the third. Okay, so let's try this one more time here. They want all the missing angles here, so I'm going to do a squared equals 7 squared plus 10 squared. I keep forgetting what the formula is. Minus 2. So these are my two sides, and this has to be the angle across from what's on the left. Just plug in though. So I've got 25 Okay, I'm going to do the rest of this in one shot. Just 25 minus 49 minus 100 divided by negative 140. So I get cosine of alpha is equal to 0.8857. If I inverse that, I get a unique answer. So alpha has to be 27.66. Okay, we could do this again to find beta, for instance. So let's do 7 squared So I've got, well, so I got 49 minus 25 minus 100 divided by negative 2 divided by 5. Okay, so I get cosine of beta is 0.76. Inversing this will give me a unique answer of 40.53. All right, I've got two of the three sides angles in a triangle, which means I know the third as well, because all I got to do is add them up, take them away from 180, and I have the third angle. Okay, that's the end. So so let me again talk about what's happened here. So in the law of sines, we needed a complete ratio, and we ran into trouble if we had the complete ratio but only one angle. Law of cosines is going to cover the other situations that we can find ourselves in, where perhaps we have all the sides and no angles at all. Law of cosines can help us there. Or law of cosines will help us where we have one angle and two sides, but we don't make a complete ratio anywhere. It fills in the gap for the law of sines. The other nice thing about the law of cosines is that it doesn't create these ambiguous cases, because inverse cosine goes into the first and second quadrant, so we get unique angles every time. Okay, hope that makes some sense.